Hey guys, welcome back to the channel. Today I'm in Westfield, New Jersey, and I am rewiring and getting rid of old knob and tube circuits. Now, knob and tube was the first wiring system that we had to wire houses and buildings, starting in the 1890s. Up until about 1930 is where I think they stopped using it because the armored cable that we now call BX cable first became available. And the improvement over knob and tube with the BX cable was that the BX cable actually had what we know now as the equipment grounding conductor. So the actual sheathing that goes around the cables is called, that's the BX portion. And that actually acts as the equipment grounding conductor to safely return fault current back to the source to facilitate the circuit breaker and clear the fault. The equipment grounding conductor is defined by the National Electric Code as a conductive path that is part of an effective ground fault current path and connects normally non-current carrying metal parts of equipment together and to the system grounded conductor or to the grounding electrical conductor or both at the main disconnect. We still use that wiring today, but we no longer can extend knob and tube circuits. It just doesn't meet the code. And so we'll start down here in the basement. I've already gone through all of the house and there's a lot of stuff here to do. Mostly this living room that's above me over here. The kitchen wiring actually has a sub panel that's actually in above a toilet. And so the definition for a bathroom by the National Electric Code is a area with a sink and a toilet, or one of the toilets or a shower is how they define it. The National Electric Code defines a bathroom as an area including a sink with one or more of the following: a toilet, a urinal, a tub, a shower, a bidet, or similar plumbing fixtures. This is how the National Electric Code defines what a bathroom is. We're gonna have to also relocate that sub panel. There is some wiring that's going out to the garage that's a little shady. I'm gonna fix that up a little bit. I'll show you that in a little while. So there's nobody actually living here right now, but the house, somebody does live here, they're just not here now. So this job does have a timetable on. It's gonna take me a while. I'll be here for a few days for sure. Anyway, a lot of the first floor receptacles we're gonna rewire today, put them on a new circuit or an existing circuit, whatever makes the most sense. And then upstairs, there's a couple bedrooms that have knob and tube wiring. And the good news is there's only a couple of receptacles in those rooms. There's actually one in each room. So in 1925 in the wired houses, to have more than one receptacle in the room was a real luxury. But then again, there weren't that many electrical appliances. So when you don't have electrical appliances, there's not that much demand. And of course, we know since 1925, 100 years ago, demand for electricity is just off the charts. I'm very grateful to be here. Let's get started. And I'm gonna show you a little bit around the house. Okay, so what we have here is an Eaton portable generator wiring box. As you can see, most of these breakers are labeled. I don't know how accurately. I do like the Eaton Cutler Hammer portable generator wiring box that's there. Anyhow, this is the knob and tube circuit that's going to go upstairs to the attic. We'll be rewiring that, and I believe 2 receptacles up on the second floor that are connected to that. It's a 100 amp main breaker Siemens panel, and as you can see there, that's the portable generator wiring box. So this is some existing knob and tube. Looks like some stuff got disconnected from it. I'm not sure what. I'm just watching this video actually for the first time now as I'm editing it. This house was built in 1925. It's good to see the jumper between the hot and cold water pipes at the water heater. This house has a boiler, which is not very common anymore, but in older houses, it's a very good heating system. And a lot of old houses still have the boiler intact and in place for the hydronic heating system. So this lighting circuit, obviously, that was connected to the knob and tube. I found out once I turned off the circuit breakers. And that's how I figure out what's connected to the knob and tube. I turn everything on in the house that I can. Lamps, lights, check receptacles, whatever I got to do. And then I turn the circuits off that I know are connected to knob and tube. And then I go throughout the house to see what's working and what's not working. And whatever's not working needs to be addressed individually, one at a time. Now what I'd like to do, and as you can see here, there is some armored cable, the BX cable, that's connected to the knob and tube going to some device boxes like the receptacles and the switches, that sort of thing. However, upon further investigation, I did find out that a lot of those BX cables were not properly terminated to the metal boxes. So therefore, there was no equipment grounding conductor there anyhow. So that all has to come out, and we need to either install a new box or connect to the existing box if that's possible. I've replaced 2 or 3 of these boxes here. One of them was a 2-gang metal gem that we put in, and then 2 receptacles in the living room. We wound up making the hole cut out in the baseboard a little bit larger, and we put in plastic boxes. So there you can see how they extended it. That 1900 box was added later on. It was just connected to the knob and tube circuit, and then they ran armored cable out of that box to new things down in the basement, or to the first floor, wherever the stuff was going. Like I said, this is the first time I'm watching this video back. So there you can see how they did it. So it's somewhat of an improvement to have protection around the cables. But obviously that's not very safe like that, especially if there was a problem with the circuit and it started arcing. That would be a big problem. Nowadays, we have splices inside of a box, as you see there. Anytime you see a flying splice, definitely not a good electrical installation. You can see the old honeymooner style switches there, the old push button. If you have an old house, or if you've been in an old house, you've seen those before. I call it the honeymooner switch because I'm a big fan of the honeymooners, and whenever I'm watching, I always notice that switch by the door because that's what electricians do. And as you can see here, there's a floating splice. That's how they extended the circuit there from the BX. So this is just one nightmare after another here. I wound up ripping this all out. It goes to the switch here, or it goes to this receptacle, and the light gets plugged into the receptacle. So we took all that out. This right here was an old Edison base fuses that actually went out to the garage. There's a piece of UF cable at the bottom that goes out to the garage, and that was working, and I found out that it was actually connected to a switch in the kitchen, and the switch was taped off so that nobody would inadvertently mess with the switch and then turn off the power to the garage. So why it was like that, I don't know, but we'll be getting rid of that and getting rid of all that knob and tube, including that old sub panel that's there, and resupplying a circuit for the garage. By the way, if you like this video, do me a favor, hit that like button and hit the subscribe button if you want to see more content like this. I appreciate everyone who subscribed in the last couple of years. Thank you very much for being here. Leave your comments and questions down below, and let's get into the meat and potatoes of this video. We're going to do, I already checked this out. So there's this 30 amp line, which is here, which goes around underneath this asbestos insulation pipe here, underneath, and it supplies power. I've already examined that. There's a few of these branch circuits that actually go this way, which is going to help when we relocate this panel. But mostly what's going to happen here is a lot of these conductors up here are actually going to go into a junction box, and then we're going to extend it with either some PVC or some EMT from the junction box back to the new panel location. It's 4 wires, so we're good there. I think it's on a 30 amp circuit. And this is the dishwasher, the refrigerator, and a bunch of stuff in the kitchen. So instead of opening everything up, we're just going to extend these circuits and obviously get this out of the bathroom. And it's a bathroom because there's a sink nearby in the area. The code specifically says the area which makes up the bathroom, a sink, and either a toilet or a shower, which we have. So this area, we could definitely say, is a bathroom. What we're going to do is we're going to relocate that panel over to here, where there's more room. There's more room to work on the panel. We'll put a board up here. I'm not going to consider that a violation. We could just cover that up. I'm okay with that. There was some decent wiring in here, not a lot. Here's some more knob and tube, all right? And that knob and tube goes all the way back over to there for that bathroom light, okay? Obviously, we want to clean up this wire just kind of flapping in the breeze here. If you haven't already liked this video, please do that. And I hope you guys enjoy this content and you learn something from it. Let me know if you do. Thanks. By the way, these are the 2 circuits right here. It's circuit CB number 5. I don't really recall that. Usually we do, the left side is all odd numbers and the right side is all even numbers. And this is the system I put in. I checked this out. It's all wired correctly. It's not how I would have done it. I always like to have my inlet outside, so you wouldn't inadvertently start your generator inside, but you'd have to get the generator down these stairs, and I don't know if you can do that. I'm going to leave this in place as it is. We got the interlock, so the supply comes into here, and Once we turn this off, then we could slide this up, and that'll allow the generator supply to go on. This is actually still available. It's pretty good. It's got the circuit breaker enclosure all built into one unit, which is nice, but you're limited to the amount of circuits that you can use. You're only going to be able to put them in the sub panel. So that's why I like to put the interlock in this panel, and then you really have the freedom of choice. But this model is pretty nice with the inlet, the circuit breakers, then of course the watt meter that's built in, which is also a really, really nice feature. So you can see how much watts you're actually using. There was a legend over here, whoever did this did a nice job. These are the main panel breakers, so I'm not exactly sure what's in here. I don't know if this was ever labeled. I had the panel cover off before, but basically what they did was disconnect a bunch of these circuits, including this one. This is also a knob and tube circuit. So we'll turn that one off, and we'll turn off CB5. That's all our knob and tube circuits. Let's go upstairs and take out our first receptacle. This one's actually pretty nice. It's got a GFCI receptacle here, which is the code for when you replace receptacles connected to knob and tube circuits. You just have to put no equipment ground sticker on the plate right there to be compliant. So sometimes you never know what you're going to find, and I wasn't expecting a handy box to be here, which is not a big deal. But as I found out, the connector is not connected to the box, so therefore the armored sheathing around the conductors that makes up the equipment grounding conductor is not bonded to this metal box, so therefore the metal box is not grounded properly. So we're going to remove this box, remove the cable, run some Romex up here, and do it right. See, the trouble is that the connector's not in the box. All right, so all you missed was me taking out this box. The KO, the seal, was never made to the box with the connector. So I don't know why, but I'm pretty sure I'm gonna run a piece of Romex up to here next. My next obstacle was to get this old piece of BX out of there. And so there's a connector on the cable that's not gonna fit through the hole that was drilled to run the cable in there. So I'm gonna have to take my multi-tool out and break this cable so I can pull it up out of the way and then pull it down from the basement so I can put the new piece of Romex non-metallic sheath cable into the opening and install the new box. And then naturally I thought this would work, but the blade is not long enough to reach the cable. So I'm gonna have to go down into the basement to cut the BX cable so that I can get it out of there and run my new piece of Romex wiring in there. Yeah, see, I'm trying to make a reach, and I'm thinking, should I get these saws all out? And so you just need to be patient. Anytime you're working in an old house, it usually takes 3, maybe 4 times longer than running something new, because you got to remove the existing wiring that's there, remove the box most of the time, and get the new wiring in place, and that's what takes time. I guess you could say the one good thing about the old knob and tube wiring is they didn't run more than one set of cables into the box. So there's never a feed in or a feed out, usually just a feed most of the time. And that was the case here. You can see that connector. Yeah. This is the circuit that I'm working on, so I'm just disconnected. Obviously, you can see they added a light there, and I guess By the timeline, you could tell that these cabinets were put in the way and they took the light out so they could fit the cabinets in there. So I'm just going to cut all this out while I'm down here in the basement before going upstairs to cut in the box. This is your typical knob and tube. I do try to remove most of the tubes that go through the joist there. But generally the knobs, I'll leave those in place because they just make a mess. It's porcelain. You're going to hit it with your hammer. It's going to break. It's going to be all over the floor. Sometimes people specifically ask me to remove the knobs and the tubes. If they don't, then I just remove the tubes and leave the knobs in place so I don't make a giant mess. Totally okay because none of that's energized anymore by the time I'm done. So you can see the wire flapping in the breeze right there, the Romex wire behind me. I think it's there someplace. Anyway, that's what I'm doing. I'm making a path to bring that wiring from the new receptacle, where I'll put in also a pull chain light over there by the boiler later on, so that they have a service light as required by the code. And then what we'll do is we'll put in a pull chain with a receptacle so they have a place to plug in. And I believe this whole circuit's going to be arc fault GFCI protected as well as required by the code. Of course, I took out a permit for this job. It hasn't been approved yet, but I think that's okay. Normally, you're supposed to do the work after you get the permit, but I was asked to do this work and I had time in the schedule to get started, so that's what I'm doing. The other thing I wish I had with me on this day was my Brute garbage cans. I have rather large ones that's probably not going to fit down the staircase here into the basement, but I do have a small one that I bought years ago, and that's going to be rugged to carry all the old armored cable and BX that's in the ceiling that we're taking out. And right now I'm just using paper bags, and of course paper bags. Paper bags break when they're too heavy, so I'm probably going to bring the small Brute garbage can when I go back there next week so that it's easy to take this trash away all at the same time. I always say to my customers, show up on time. I'm going to show up on time. I'm going to do exactly what I say I'm going to do, and we're going to clean up. And in my mind, those are the 3 points in business that every contractor should adhere to. Okay, so I pushed the wire down from up top, and it runs along this board and goes through one of the old holes where the tube used to be. And as you can see, I'm extending this through the circuit. I'll come back with my stapler to tack this cable up. But what I'm going to do is I'm going to put a round box right here, a nail-on box, and put a pull chain light. It'll be right by the utility, and it'll be right by the water heater for servicing, and it'll be a good spot for a pull chain light. Maybe we'll put it over here because I definitely see if we put it right there, right, that's my path to walk over here to this duct to either service the water heater or this duct or something on the back side of that boiler, so you can bang your head into it. So what I'm going to do is going to move it over here a little bit so the pull chain's over and out of the way, but it'll still illuminate the area so we don't bang our head like you could with this light right here. See this? You see what I mean? You see what I mean? Wow, who remembers this TV? It was really nice. Panasonic with a built-in VCR. So once my wiring is in place, I'm using a plastic box here. I'm trying to fit it in here, and I realize that even though I can get it in, it's crooked just a little bit to the right. So I'm going to wind up getting this started and pull it back out. Use my level to draw a straight line along the top there, and then I'll come back with the multi-tool to make this box a little bit wide, make the hole cut out a little bit wider, but the box and the receptacle will sit flat and level and just look just right. It's worth taking the time to do this. Alright, so obviously this is the old, look at that, just came undone. This old BX is probably spliced on like the other one was. Yeah, here it is right here. Here's the wire. Can't see it. Here it is. That's what it's connected to. Just this piece of BX wire here flapping in the breeze. Coming in out of the box to the lamp holder here. It's old school. This is a 3-inch box. Very small. Very rarely do we use these. I keep a few extension rings on my truck, so I seem to do this work a lot. And sometimes you need to extend that box if it's okay, just for box fill calculations, the amount of conductors and heat and that sort of thing. Okay, so as you can see, this one was also GFCI protected with no equipment grounding conductor present, and I'm about to find out that there's actually an old piece of Romex that's up this into this outlet box, except they just wrapped the equipment grounding conductor around the cable itself and never attached it to the box, which makes no sense to me. So I was halfway through this already, so we got rid of that. I actually have it coiled up down in the basement right now. I'll use it for something, maybe a pull chain light somewhere near where the panel box is, or for something at the bottom of the staircase. I'm not exactly sure just yet. But I was surprised to find out when I pulled this receptacle box out that they actually had an equipment grounding conductor in the cable to supply the box, but they didn't use it. So we ripped that out, we ran some new wiring, and this is what that box looked like. Hope you enjoy this video. I hope you could see that. But inside where that cable enters the box, see how they just wrapped the ground wire around there and did nothing with it? The intent is to bond this metal box. So should the hot conductor come in contact with the metal box while you're working on it, for whatever reason, that box doesn't stay energized. When it's properly grounded, it'll send fault current back to the source to open up the circuit breaker that the circuit's been affected by. Okay, so I think I finally found where exactly that wire is going up, and I believe it's right here. It's a brown, looks like brown Romex. But upstairs at the receptacle, it's like a white, so maybe I'm wrong. So yeah, equipment ground comes just wrapped around right there. All I had to do was wrap it around the box. And I wouldn't have thought that it was not the tube, it needed to be replaced. Not a big deal. We're actually going to tie on the Romex to this one here, or downstairs and pull it up. Probably from here and pull it down. And we're going to need to make a little bit of room here. As you can see where this piece of Romex is coming up. We can't have that coming up in the new box that we're going to put in here. So whatever this is behind here, I'm just going to move some of this away. This way, when my cable comes up through this hole, it'll just bounce to the back here like this. And if this is the top of the box right here, or the bottom of the box, then there'll be clearance to move that cable out of the way. But we're going to leave it like this for now and tie the cable on and pull it down so we have the wire in place. Okay, so now that I've got my wiring in place, I got to bring it to where I want to connect it to either a junction box or bring it to a panel. And that's what I'm doing here. And so while I'm there, this receptacle is flapping in the breeze. We got rid of that. It was connected to the knob and tube. Once I get back upstairs here to where the receptacle is going to go, I think this is the following day on Friday. So this box is not going to fit in here. And this one had a little bit more obstructions than the last one. Generally, box sizes have been the same ever since the start of time here as far as electrical devices go. Except this box is a little bit larger on the outside, whereas the screw holes on those old boxes used to be outside the box. The new boxes, the plastic ones here, the screw hole is actually inside the box. So that's the difference that we're making up here. Just about anything I do, I try to make it as best as it could be, as good as it could be. And I know this is just a receptacle box in your living room, but I believe I take great pride in doing a good job that I'm hired to do. I would say my pricing is competitive with other electrical contractors, but you get what you pay for. And so once this box actually goes in here, I'm pretty proud that the size was done, the extra work was taken, and this is going to be a safe electrical receptacle for the next 100 years, I hope. If this house is still up in 100 years, we'll see. We don't know what the future holds. So I'm tightening down the wings, and there's a small spot that they fit into. I checked that all out before I put the box in. So when you tighten down these screws here, there's a flap in the back that actually tightens it up against the baseboard here. And I believe this is just finger joint pine. If they had such a thing back in 1925 when they put this trim in, I think that's what they call it nowadays. That's what they would use. So it's pretty easy to cut. You just got to take your time and don't make the cut too big. Just want to make that box. You just want that box to fit in there, and then of course the cover plate's going to cover up any discrepancies on the outside of the box. But generally the code says no more than 1/8 of an inch larger than that box. Otherwise you have to repair it. And so that's what we're working with here. And this is a good installation. Now I'm just going to use my utility knife to cut back down the middle of the non-metallic sheath cable to break apart the sheathing, and then I'll come back in and try to cut it. Got to leave at least 1/4 inch of sheathing inside the box here. With this box I probably leave a little bit more than necessary, but that's not a violation as long as you have at least 1/4 inch. Then we'll rip off the paper from the equipment grounding conductor and start prepping our conductors here for the tamper resistant receptacle that's going to go here. Now I'm a little concerned that it's so low, just above that shoe molding there, but it turns out that the cover plate goes right up against it and it's fine. The original box cut out here was a little bit lower than the first one I did early on in the video, but I didn't notice that at first, and I'm glad that the cover plate actually fits on, because if it doesn't, then it looks like crap and it just looks like, you know, who did this? Anyhow, it comes out very nice here. I'll show you in a moment when we put the device in. So anytime I replace a receptacle like this, I'm supposed to bring it up to code, so that's exactly what I'm doing. Obviously the bare conductor you see that I'm tightening up, that's the equipment grounding conductor. That's going directly to the receptacle. Because the box is plastic, it's not conductive. We do not need to bond or ground the box because it's plastic and it won't conduct electricity. The other two conductors is the neutral, which is actually a grounded conductor, different than the equipment grounding conductor. And then of course finally the hot conductor, electricians will call this the ungrounded conductor. So anytime I replace something like this, I have to bring it up to code, and I'm putting in and I'm installing a tamper-resistant duplex Decorus type receptacle. I think the Decora looks nicer in the base molding like it is here. Could have used just a regular receptacle, but I have to put in a tamper-resistant. And of course, if this did not have the equipment grounding conductor, then I would have to put in a GFCI receptacle or a GFCI circuit breaker to protect the circuit, and hit the sticker that says no equipment grounding conductor on the faceplate. But because this is new wiring, all I have to do here is put the tamper resistant receptacle in and connect my wires as is, which I'm doing here all by hand. I'm not sure where my cordless drill was, but it's just one device. I can do it by hand. And so the important thing here is that when I put this cover plate on, everything is level, horizontal I should say here, and looks nice. And then we'll come back with the vacuum and we'll clean up around this area here. Now both of these receptacles you saw me here today wiring up and installing, they still haven't been connected to a circuit just yet. I'm still connecting and still diagnosing where the knob and tube goes and how the circuit's going to go. But once I do know that, I'll come back and bring these cables that go to these receptacles into a junction box to supply them with the new circuit. And then of course it's going to have to be arc fault and GFCI protected. Not necessarily for the living room, but there's going to be some stuff in the basement that's going to be on this circuit as well. So we're going to leave it. We're going to install an arc fault GFCI circuit breaker in the main breaker panel, so this will be compliant. And of course all of this work has a permit and will be inspected. I don't know what the inspector is going to look like. The inspector in this town is very fair to me, knows my work, and so I know that he knows that he doesn't have to look at too many of my things. As long as he sees the work, looks professional, it was done correctly. And I think he might even follow me here on YouTube. So if you like this video, do me a favor, hit the like button, and we'll see you on the next one. Thanks a lot, guys. Hi, this is Ron from Classic Electric. YouTube thinks that you'll like these two videos on the screen, so go ahead and check them out. Don't forget to leave a comment, like and subscribe, and we'll see you on the next video. Thanks for watching.